My name is Bob Beauchemin, and I'm a consultant for STEP Technology in Portland, Oregon. And I'm going to talk about pooled resource objects in COM+. The resource that I'm going to talk about pooling is database access. So how many of you access databases in your applications? Oh, good, good. Okay, you're in the right place. I talked to a man yesterday. I was walking down the hall, and he happened to say, you know, they ought to sort of retitle this conference to be Death by PowerPoint. So hopefully I'll be doing some PowerPoints, but I was going to try and do as much as I could in the C++ compiler environment. So I was actually thinking of trying to install PowerPoint on the C++ machine so that I could do the opposite of what the man mentioned this morning and actually do my presentation from within the C++ compiler. But it was too much work and too much hassle. So I'm going to talk about pooled resource objects. Just to sort of start with a starting point, how many of you think that MTS version 1 or MTS version 2 supports pooled objects? There's a nice little, interface for it called iObject Control, and there's a little nice question that they answered called Can Be Pooled. However, never gets asked. MTS version 1, MTS version 2 does not support pooled resource objects. On the other hand, COM+ will support pooled objects. So you can hold your applause for that till the end. I know a lot of you have been waiting for that for a long time. Pat Helen, though, the godfather of MTS, at one point mentioned that if there was going to be pooled resource objects with MTS version 3, as it was called at the time, that there would be very little use for them because MTS and COM+ runtime cache so much of the information that you need. When MTS starts up, it caches the TLB information, the extended information that MTS uses, like the transactional properties, the just-in-time activation, also caches your class factory. So to create a new object in MTS is like that. So the concept of pooled objects in COM+, the main concept of pooled objects in COM+, is that if you don't have a long constructor or have a precious resource or have something that takes a long time to do, in your iObject Control Activate, which I'm sure you've all written, then you have no need for pooled objects at all, and you can leave. However, for those of us who do, pooled objects are going to be very interesting. So first of all, I figured out one of the reasons why we had to have PowerPoints have to talk about the sponsors. And let me put everybody back on the same PowerPoint now. I will be getting to code. I will be getting to new code. I am going to have to go over some of the old stuff, though, and it's going to have to be on PowerPoint. So having done the obligatory, I've actually bought some of these folks' products. Having done the obligatory sponsors, we'll go on. The agenda for today is to build at least 2 and possibly 3, or not build them on stage, but go over them, pooled database access resource object using the COM+ object pooling model. And so I'm going to talk about data access in COM+. I'm going to talk about the predecessor that still exists to pooled objects, and it's very useful, called resource dispensers, and I'm going to talk a little bit about how those work. If you don't know how the internals of a resource dispenser works, you'll know now. Then I'm going to talk a little bit about why object pooling. Why would you ever want to do object pooling if the resource dispenser architecture is so wonderful and these resource dispensers are so great? Then I'm going to build, I'm actually, like I said, not going to build, I'm going to show an ODBC data resource object, and then because OLADB is becoming the preferred method to access data, I'm going to build an OLADB data resource object. And I'm actually going to do some things at the end that are kind of interesting, like merging OLADB and ADO, because I want to build my data access in OLADB so that it'll be as fast as possible and so that I can manually enlist in transaction. But on the other hand, my consumers who may be Visual Basic components may want to consume ADO, and so I'm going to show you how to get around that. Okay, so this is the first slide. This is kind of obvious, but data can be accessed in COM+ by OLADB and ADO, ODBC and RDO, native methods like OCI or DBLib, and any method, really. If you consider sockets data, sockets have access to data, then the data in COM+ can be accessed by any method you'd like. The preferred method, though, let me say again, and the method that we're going to is OLADB and ADO. And the reason for that being the preferred method is because, simply, it's COM-based. Okay, so talk a little bit about resource dispensers. There is new stuff coming up, so don't worry. MTS introduced the concept of something called a resource dispenser. And MTS, or there were actually some resource dispensers provided with MTS and some built after the introduction of MTS. The one that was immediately provided with MTS on release was the ODBC Data Access Resource Dispenser. This is accomplished, as you all probably know, by the fact that the ODBC 3.0 and above driver manager is an MTS resource dispenser and will automatically enlist your resources, your ODBC connections, and transactions. The OLEDB folks, not to be outdone, came out with their own resource dispenser, and we're going to talk a little bit about that too. I have a slide on it. OLEDB 2.0 and above provides a resource dispenser for OLEDB-only resources. In other words, not the OLEDB provider for ODBC, but the OLEDB provider like SQL OLEDB or MSDA Aura. That's provided by OLEDB 2.0, and that actually works by means of aggregating on top of your provider with what's called service components. And there's a couple talks on this during the PDC, and you might want to check those out. There's also a resource dispenser for mainframe connections. This is connections to the IBM mainframe and connections to CICS or IMS, and this is known as COM-TI, the COM Transaction Integrator. It used to be called COM-TIKI, the COM Transaction Integrator for CICS and IMS. So those are the ones you get. Now, how do they work? Resource dispensers, when they start up, register with something called Dispenser Manager. Dispenser Manager, if you want to know his name, lives in mtxdm.dll. Dispenser Manager keeps a resource holder for the resource type that you register. So conceivably, you can build your own resource dispenser and register as many different kinds of resources as you want. Disman, which Dispenser Manager is conveniently known as, to keep track of. So Disman keeps a resource holder for each resource type for you, and this is how Disman works. Every time I want a new resource, I go to, say, ODBC. ODBC goes to Disman. Disman says, do I have one in my inventory? If not, he goes back to ODBC and asks for a resource. And this has been around since MTS version 1. What that entails is the fact that the resource inventory, in other words, the number of open ODBC or OLEDB connections I have in my resource pool, grows with demand. But of course, it couldn't grow forever. We'd run out of memory and we'd run out of connections. So what happens is that Dispenser Manager checks for timed out resources every 10 seconds. And so every 10 seconds, Dispenser Manager goes around and says, I can pass a timeout value into Dispenser Manager. Are any of my connections timed out? And the ODBC connection timeout value that's set by default for ODBC connections is 60 seconds. The idea being, if I set the timeout value for 60 seconds and I have one person hit my website and want an ODBC connection every 61 seconds, I'm now actually probably going out and getting a new connection for each one. So that's the governing thing that you can put, and that's actually an entry in the registry that I'll show you where it is later on. But the idea is that the resource grows with demand. Dispenser Manager checks for timed out resources every so often. He wakes up and looks around. Okay, talk about database resource dispensers, because that's what most of the talk is about. Resource dispenser architecture provides an infrastructure for connection pooling. We actually aren't pooling connections as far as Disman is concerned. We're pooling opaque handles. We just happen to know that they're database connections. And also, the Disman infrastructure provides a method for automatic transaction enlistment, which is why in your MTS program or your MTS components, you don't have to ever manually enlist in a transaction, because MTS goes up, he reads his metadata, he sees that that component is part of a transaction. Any ODBC or OLEDB resources that you open in the context of that component is part of that transaction. So Disman does this automatically. And the way Disman does it is that he gets the transaction object, the pointer to the OLE transaction object, from the context, the MTS object context, and provides it to your resource dispenser. So Disman gets a transaction, he provides it to you, no big deal. Talk about the two we have. The ODBC resource dispenser, like I said, the driver manager is the ODBC resource dispenser. It provides database connection pooling, and that connection pooling is configurable in the registry. If you want to change the connection pooling, what you do is change the CP timeout value in the registry key, and I'll show you where that is later on. ODBC also provides automatic transaction enlistment through a call called SQL set connection attribute. And this is only if the automatic transaction or transaction enlistment at all is supported by your ODBC driver. So right now, the SQL Server ODBC driver supports automatic transaction enlistment. The Oracle one does, the DB2 one does, the Informix one does. Right now, other databases like Sybase, I don't believe support it yet, although I heard they're in beta as well. The idea, though, is that if you're part of that resource pool, the ODBC driver manager will automatically try to enlist your connection in a transaction if the component that you're calling it from is transactional. So that's why you never see any begin transaction in transaction server components. There is no such thing. They compose. But you all know this. You didn't come to hear that. ODBC 3.5 configures pools by driver. Now, why would we want to configure pools by driver? What does this possibly get us? And it turns out that if I have a pool of connections, and half of them are SQL Server connections and half of them are DB2 connections, and I'm looking for a connection that's one for me in the pool, why should I have to go through all the DB2 connections if what I really want is the SQL Server connections? Does this one match? Does this one match? Does this one match? You're going to be going through them for a long time. So the idea is that ODBC 3.5 will allow you to configure separate pools for each driver. Only makes sense. Here's the OLEDB resource dispenser. Like I said, 2.0 and above provides resource dispenser. It provides a resource dispenser through something called the service component architecture. The idea being that as far as OLEDB 1.5 was concerned, if you wrote an OLEDB provider, that OLEDB provider had to support COM aggregation. And the reason why it had to support COM aggregation was because the OLEDB service components were going to aggregate on top of your resource dispenser. I'm sorry, on top of your provider. So the service components aggregate over top of your provider, and the service components can provide such nice things as connection pooling and automatic transaction enlistment, just what you'd want. They also provide such things as, client-side cursors and things like that. The OLEDB resource dispenser optimizes pools for multiprocessors. So they'll actually, besides kicking off one pool for each type of connection that you have, kick off a separate pool for each multiprocessor. I'm sorry, for each processor in a multiprocessing environment. Okay. The OLEDB service components are configurable in the registry. This is the automatic services, and they're under HKey classes root, class ID, and the provider ID. This is the GUID of the provider, and then OLEDB services. This is a per machine default, and this is a bit flag that you can set. Except for the OLEDB provider for ODBC, it's usually set to all Fs by default. So for example, if you wanted to do something like turn off automatic transaction enlistment, you just turn one of those bits off in the registry, and automatic transaction enlistment is turned off for OLEDB for everything on that machine for that provider. However, that's kind of rough-grained. It's also configurable programmatically. And the thing that it's configurable by is the data source object properties in OLEDB or the ADO connection object. And this is per connection, so I can have some of the connections in a process that have these and some of them that have different values. Whoops. Okay. So OLEDB, as you probably know, supports distributed transactions by means of an interface called iTransactionJoin. ADO, on the other hand, only supports local transactions. So there is right now in ADO 2.0 no bit I can flip to say, manually enlist this in a distributed transaction using DTC. However, iTransactionJoin, the OLEDB interface, is supported by SQL OLEDB, which is the native SQL Server provider, MSDA Aura, which is the native Oracle provider provided by Microsoft, and actually also MSDA SQL, which is the OLEDB provider for ODBC. It's also supported, iTransactionJoin is, by some third-party providers like the ISG Navigator. ISG Navigator supports iTransactionJoin, so you can call that. This gets to be more important as we move into pooled objects because you're going to be calling this. That was what the code sample I had up at the beginning of the lecture was. Okay, so why would I use a resource dispenser? Resource dispensers are extremely convenient to use. The resource dispenser is totally invisible to you, provides automatic connection pooling, provides automatic transaction enlistment, and I don't have to change my programming style at all. You've, I'm sure, never written an iTransactionJoin interface ever if you've programmed MTS. Transaction enlistment is automatic, connection pulling is automatic, resources are garbage collected via timeout value. This is really nice. If the resource dispensers don't have the properties you want, there's an SDK example. You can write your own resource dispenser. So I believe the SDK example writes a resource dispenser and a resource manager for implementing a transactional file copy, I believe. So why would you not want to use resource dispensers? Well, the first question that people ask when I talk about how to configure the resource dispenser connection pool is, how do I set the number of connections in the pool? I've just gone out and I've bought SQL Server, and I've bought 100 SQL Server connections, or I have SQL Server 6.5 generated to use 100 SQL Server connections, and I only want to use 100. How do they configure that in the connection pool? And the answer is, you can't. Like I said before, the number of connections in the pool keeps on growing. Every 10 seconds, dismantle, turn around, and ask if there's any timed out. So if 101 people hit your site all exactly at the same time, the first 100 get some nice SQL Server connections because you happen to have them available. They may even be in the pool. The 101st person that comes in gets a nice quick, sorry, I'm out of connections. Now, in a transaction server environment, or in a COM+ environment, you might want to say, well, I know that I'm only using the connections in a transient manner. Why don't you just wait a little while? I know there's going to be one available. Just wait. Don't time out right now. Well, I can't do that either. And in fact, if I asked once, when do you stop allocating connections? The idea is that the pool, if there's no timeout value, if you set the timeout value to infinite, will continue to allocate connections until you run out of database connections, or you run out of processes. Say if you're connecting to an Oracle database in Unix, you might run out of processes, or until you run out of virtual memory. So this might not be something in a web scenario that I might, want to let go like that. Again, the only way that I can configure this is by the timeout value. So the other thing that might be nice to do is the connection pools don't really wait if a resource is not available. If a resource is not available, like I said before, they'll just come back and say, sorry, we're out. The last thing about resource dispensers, which the dispenser writers are always trying to improve, and there's been improvements made even in latest version of ODBC, is that it's time-consuming to search through a pool for a matching connection. Usually in a connection pool situation, the connections have to match. If I have a connection that says user ID equals SA, and then I want another connection that says user ID equals Bob, those connections aren't going to match. I'm not going to do any automatic reset at disconnect time. So I have to search the pool. Let's see, is this one SA? Is this one SA? Is this one SA? And if I have a lot of heterogeneous pools, or if for some reason I'm using MTS or SQL Server Integrated Security or Oracle Integrated Security, and actually logging onto the database as the NT user, this is not going to do very well with connection pooling. So, like I said, if I have a heterogeneous pool, it's time-consuming to search through the pool. So, into this mix comes COM+ pooled resource objects. And the pooled object, let me switch these over to the COM+ Explorer. Take down the code for a second. Bring up the Explorer. And I'm sure you saw this yesterday if you went to Hugh and Tracy's talk, and probably saw this today also if you went to Jeff's talk. See, I was all prepared. Okay. It turns out that there's a nice tab that you can configure on a component-by-component basis. Hello. It is really extremely difficult sometimes to do demos based on the latest version of beta software, because people want to show all the new great features. There we go. But sometimes the new great features have just been invented by somebody yesterday. Okay, here's the sample bank application. And here's bank account VC. And I'm sure you can't see this from the back, so I'll read it to you if you don't already know this already. On the Other tab, because it's one of these other functions, on the Other tab, there's a checkbox called Enable Object Pooling. And if I'm able to enable object pooling, then check that box. And there's three nice configurable things that I can configure in there. One of them is the minimum number of objects in the pool. I can set that to whatever number I want. Another one is the maximum number of objects in the pool, and a creation timeout. Creation timeout is the amount of time it waits around if there's not an object available. So this is really nice. If you think about the previous slide, this maps back to almost exactly what I want. Okay. So those are the three declarative things that you can set about pooled resource objects. You can see where I'm going with this, right? Okay. The other thing, though, is that pooled resource objects aren't for everyone. Pooled resource objects have to be able to be used in different components and different transactions on different threads. And so any language that is not able to make components that can be used on different threads, say, for example, they use thread local storage. I'm talking right now Visual Basic 6 is one that comes to mind. I cannot right now write a COM+ pooled component in a language that uses thread local storage. So we're going to have to wait around for the next version. However, I can, all my pooled components are written in C++, and I've been told by the Java folks that J++ is able to write them as well. I just haven't specifically written any. So also, besides the language considerations, they're only good if the objects that they have, or the objects that they represent, are homogeneous. I have to be able to get an object from the pool and have it look exactly the same as the last object I got from the pool. And it's only useful if I have a long constructor, because like I said before, MTS and the COM+ runtime will cache tremendous amounts of things on your behalf, and it's only if you have a long constructor that this matters, or a precious resource. Now, precious resources might be such things as socket connections. They might be objects initialized from disk or registry where it's time-consuming to hit the disk, or they might be, surprise, surprise, database connections. And again, I use object pooling if the time to construct is long in comparison to the time used. So there is some drawbacks, so there is some interesting things about writing pooled resource objects. If you write a pooled resource object, you manage the transaction enlistment. No longer do I have this nice ODBC driver manager that calls distman for me. You have to manage the transaction enlistment yourself. However, the pool manager helps you out with this. The pooled object pool manager, he keeps track of separate enlisted and unenlisted pools. And so what he'll try and do is if you're in a transaction, he's going to look through his enlisted pool and say, is there one there that's in the same transaction? If there is, give him that one. Because transaction enlistment is expensive. I'm sure you know this sort of as an aside, but the two most expensive processes usually in dealing with database are connecting to the database and enlisting in a transaction. I used to have an application that I wrote that did tremendously long queries, in fact, 4 tremendously long queries from a CGI program long ago. And those tremendously long queries took a long time in database years. On the other hand, it took me 3 times as long to connect to the database as it did to do these big honking queries. So the idea is that connection is expensive, transaction enlistment is expensive, you're going to manage connection, and pool manager is going to help you out by managing separate pools of enlisted and unenlisted components. The other thing that has to happen, of course, so that you can do manual transaction enlistment is that the OLE transaction object is now available to you. So you have control over that. There's a new interface for that. I'll show that later on. So the idea is that because I have all this stuff now available to me, this is sort of the equivalent, sort of kinda, of a lightweight resource dispenser. So I'm going to implement pooled objects as a lightweight resource dispenser. Now there's also some more requirements for pooled objects, of course, because this isn't going to be easy. You know, this is the opposite of what Hugh Teagan was talking about yesterday when he talked about sharing, carrying, you know, place to put your components. This is you write it yourself and you manage it yourself. Pooled resource objects can't possibly have any thread affinity because I might be used one time on one thread and one time on the next thread. They can be, though, multi-threaded apartment components if I'm only going to access them from the MTA, or neutral threaded apartment components with the new neutral threaded apartment, or they can also be threading model of both, or actually, as it's known now, all. So they can be any of those threading models, but they have to be able to be used on different threads at different times. The other thing about pooled objects is the fact that they must be aggregatable. And this is because of the way the pooled object works. The way pooled object works is that when you get a pooled object, the way that your object is kept alive is that your object is aggregated by this object called the object life object. And the object life object keeps an extra reference to your object. So no matter how many times I call, you know, release, I always have an extra reference kept by the object life object. Well, object life aggregates over top of your component. So your component, Bob's component, or anybody's component, has to be aggregatable. If you don't support aggregation, if you don't support being past a unknown pointer for a controlling unknown, then you're not going to be able to play pooled objects. On the other hand, pooled objects cannot be aggregated. Once I get the pooled object back, I can't aggregate over top of it. So they must be aggregatable, and they can't be aggregated once you get them back. The other thing that's kind of interesting is that pooled objects really shouldn't aggregate free-threaded marshaller. Free-threaded marshaller is a nice way to make sure that all your object references or all the hits to your object are really quick. On the other hand, they interfere with some of the mechanisms that pooled object uses. And so you really shouldn't, you're not forbidden from, but you really shouldn't aggregate free-threaded marshaller in a pooled object. Pooled objects also have to manage your own state. Like I said, the resource dispensers and usually the MTS and COM+ environments do some of this for you. You must manage your own state yourself. And you also, it's an absolute requirement that you implement iObject control, because this release, they're really going to listen, and when they call can be pooled, they expect an answer back. And what's interesting is that you can answer yes to can be pooled some of the times and no to can be pooled some of the times. We'll talk about a little bit of the repercussions of that later on. Now, I'm sure there's a whole bunch of people out there that are saying, but I made Visual Basic components in Visual Basic 5, and I implement iObject control, and I answer yes to can be pooled. What about me? And the idea is the folks that were inventing this had to think about this. You absolutely have to be configured for object pooling. So I don't care if I implement iObject control. I don't care if you answer yes to can be pooled. If I don't have that box checked, it's not going to happen. So that's kind of a nice thing. You don't have to worry about backwards compatibility with your old components. Okay. So talk a little bit about pooled objects in XA databases. Remember that COM+ components or COM+ transactions, the transaction model they use is called OLE transactions. The object model that some of the rest of the world uses is called XA transactions. And XA transactions enlist in transactions by means of an XID, or an X transaction identifier. OLE transactions enlist in DTC, and they use the enlist in DTC connection attribute, or iTransaction join in OLEDB. Even if I have an XA database, like Oracle or DB2, I have to manage in my pooled component, because believe it or not, this is what the OLEDB providers and ODBC drivers do. I have to actually enlist my connection in the OLE transaction, even though I don't support it. And I have to take care of making sure that when I get the proper things back, that I do the right thing as far as the XA transaction is concerned. And in order to help you with this, it turns out that DTC has a table that will map TRIDs, which are OLE transactions, to XIDs. And so you can do this yourself. It isn't trivial. Okay, so now I'm getting to code. I'm going to start with the tale of two pooled objects. One of the objects is from the COM+ SDK. Everybody knows the COM+ SDK comes with the latest version of the platform SDK, which is on the September CD of MSDN. So if you have that, you have the COM+ SDK. Look under Samples, COM, Services. See a lot of good stuff. There's a directory under there that's called Object Pooling. And what they did is they took the C account object from the sample bank application and pooled that. So I'm going to show that. That object uses the ODBC API. So we're going to look at that one. You can look at that one when you go home. Of course, remember what I said in the first slide, the preferred data access method is OLEDB. So I went and built an OLEDB object that does about the same thing, in fact, clones some of the same code that's actually going to use OLEDB. Now, I started out actually with a totally generic object that did all its manual transaction enlistment in OLEDB and passed you back and forth ADO record sets. And I'm going to show that object if I have time, but that's a little more complicated, and I just sort of wanted to show the general idea. So what I'm going to do here is sort of a little different than you've been used to, which is that I'm going to show the code, and then I'm going to go back and go over what specifically in the code you have to worry about. So let me do that now. We'll see how long it takes them to get the code up. These guys are both written in ATL. They're just regular ATL components. I implement, or the people who write them implement I support error info, so we'll have rich error information. I also just implement two interfaces. One is called iObjectControl, which is the one you have to implement, and the other one is iObjectConstruct. Because if I'm going to be doing database connections from within components, I might want to do something with my database connection like change the password. You know, security administrators, auditors, people like that do like to see the SQL Server passwords changed every once in a while. And so if I'm not using integrated security, I do have to go in and change those passwords. And if I have those configured in the component, I don't want to have to go back and recompile and redeploy all my components just every time the password changes. So let me, as an aside, which really doesn't have anything to do with pooled objects, but is kind of interesting because it has its own set of properties that you have to watch out for, is something called object construction. And if I check this box here, I enable object construction. That's what the box says for the people in the back. Enable object construction. When I do that, I can type anything I want to into this construction string. And what I might want to type in there if I have data objects is a DSN, a user ID, and a password. So I can type that in the construction string. You'll notice that there's also the possibility in these examples of typing /np in the construction string. And basically what we do is look for the string /np, the substring /np. And if it exists, then we say, don't pool this object. So you even have the choice at configuration time as to whether or not to pool this object. Okay. So here's the C account object from the sample bank. First thing I want to show you is, come on, there we go, how the construction string works. Basically what you do is you implement in your object iObjectConstruct. And iObjectConstruct has one method that's called construct. And when the object is in the construction phase, a control will be passed to your object with an unknown pointer. And it's up to your object, if it wants that string, and this object wants that string, to QI for iObjectConstructString. So that's what this object does. It uses the p unknown, the pointer to the unknown, to QI for iObjectConstructString. If it gets that, then what it'll do is just go back and read the string. Now, why would you go through all that hassle just to read a string? Couldn't I read it out of the registry or maybe something else? It turns out that there's only one string today, so I may have to pass everything in one string today, but you might be able to infer where it's going from the future. That maybe I'll be able to pass more things in strings. Maybe I'll be able to pass property bags or other things. So right now I can only get this one string. But I get the one string, I search the string for the /np, and basically I have a member variable that's a Boolean that says whether or not the object is pooled. So the person who wrote this component decided that this was actually a good place to do get connection. And so he takes the things from that construction string and goes out up here and does get connection, passing in the environment handle for ODBC. And notice that the environment handle and the database connection and the H statement are all member variables as well. Because remember, if I write a pooled object, I have to keep track of my own state. And so I'm going to keep track of these in member variables. Okay. So let me go to get connection. So you don't have to follow this at home, or you can go home and follow this again. Here's get connection. I pass in all these pointers to all these things. And I go and allocate myself an ODBC environment. And what I have to do is make sure that the automatic stuff doesn't get in my way. If I'm going to manage this myself, remember that the automatic stuff might latch onto it and try and do exactly the same thing as I've been doing. So what I do is set the SQL environment attribute for connection pooling right here to off. So I turn connection pooling off. Basically, I'm managing my own connection pooling, so I better know exactly what I'm doing. Okay. Then I allocate a connect. I do SQL alloc connect, SQL driver connect, and now I have a connection to ODBC. Notice that I didn't enlist in the transaction right here. And the reason is, and this is extremely important, that when your iObjectConstruct interface gets control, or when your construct method gets control, you don't have a transaction yet. Don't even try. There's no transaction available to you at this point. Okay. But the next thing that happens after I object control, and notice I already have a connection. Come on, stop this. Okay. Almost. Notice I already have a connection. The next thing that happens is I object control activate. Come on. I did have it set up in the C++ API and had all these things nicely configured. There's activate. Okay. So activate has a flag called should enlist. Activate is the first place that I'm able to get a hold of the transaction if I want to. However, what I choose to do in activate, or what the person that wrote the object chooses to do, is if the object isn't pooled, don't even bother. Just go back. I'm done. If the object is pooled, what I'm going to do is go get the object context. There's a new call for this, by the way. There's one called co-getObjectContext. I can use that or just the regular getObjectContext. I use getObjectContext. I QI for the new interface right here, which is iObjectContextInfo. And the two pieces of information that I'm interested in from iObjectContextInfo are the pointer to the OLA transaction and the TRID, the unit of work that the OLA transaction is encapsulating. So I can actually get the TRID, which is a GUID, by the way, by saying get transaction ID. So I use that interface right here to go out and get the transaction ID. Now, why would I want the transaction ID? Well, remember that I'm going to manage my own state. So I store the transaction ID in a member variable called m_tx_uow. UOW is unit of work. So if my unit of work is the same as the unit of work that this component is already has, then I don't need to manually enlist in the transaction. In fact, it'd be stupid for me to do it. It'd be expensive. So if it's not equal, then should enlist equals true. Else should enlist equals false. And again, I do this so I do as little work as possible. So now I have a connection. In fact, I'm going to always have a connection because I'm never going to let go of it until final release. I also have the ability to know if the unit of work is the same if I should enlist. So now what happens is this guy calls something called do work, which is, I'm flipping through these things, right here. And do work is actually the work you want to do. Now, in a normal MTS environment today, what you would do is in do work, you'd go get yourself a connection, it'd pick one up from the pool, you'd go do your work, and you'd release the connection. That's the way it's done today. The way that it's done with the pooled object is you already have your connection. In fact, he's already connected. I also know that whether or not I want to enlist in the transaction or not. So if I should enlist, right up here, if member_b should enlist, then I go and I call this routine called enlist. And then I go and do my work. It's fairly easy to call to enlist in a transaction. It's not rocket science. And here down here is where I enlist in an ODBC transaction. I use that same iObjectContextInfo interface right here to go out and get the p_transaction object. And for people that have heard me talk about this before, the p_transaction object is the magic object that I have to pass to either iTransaction join transaction or SQL set connection attribute enlist in transaction. However, the person that wrote this called a deprecated function that does the same thing called SQL set connection option down at the bottom. Now it's up at the top. Okay, so I call SQL set connection option, and the option that I want to set is enlist in DTC. And remember, I'm going to do this whether I have an OLA transaction database or an XA database. I always enlist in DTC. And then I pass it the magic pointer to the transaction object. So that's all I have to do. If I get an error doing that, then I say fail to enlist on the caller's transaction. Now what's nice about this is that if I have a database that can't enlist an OLA transaction today, but might be able to enlist tomorrow, I can still write this code. And I can just handle the error a little differently. Right now, if you call the ODBC and go through the connection pool in the automatic transaction enlistment, there's no margin for error here. You have to mark all your components that use this as transactional or non-transactional. So it won't automatically try and do this. So basically, that's how I do it in ODBC. Now I'm going to show you the other really simple one for OLADB, and you can imagine that I wrote most of this with my two favorite keys, the cut key and the paste key. Okay, I never write code. So I'm going to do something a little different, though, than this guy did. In construct, I just go out the same way as he did in construct and look for /np, and it's exactly the same thing. However, I'm not going to get my connection here. I'm going to wait a little while before I do that. I'm going to do lazy connection. I am, however, going to go out and activate and decide whether or not I should be enlisted in a transaction or I should try to enlist in a transaction. And this is exactly the same cut and paste code as well. Okay. When I execute my operation, which is the thing that I'm going to do, this component is a little more generic than sample bank component. This component takes a database SQL string, tries to execute that SQL string, and returns back to you the number of rows affected. And it does this in a method called execute operation. So what I do is in execute operation, I go and try and figure out if it should be pooled, and if it isn't, then I'm okay. Then I also figure out if it's constructed already. And if it's not constructed, then I go get the connection. So let's see how to get the connection in OLADB. This is a little different. It's down at the bottom. Okay. I'm going to use the new style means of getting a connection. I'm going to use idata initialize. And one of the reasons why you'd use idata initialize is to get the automatic OLADB services. But then I'm going to go and disable the automatic OLADB services. And here's where I do it. Right down here, I set the initialization properties. So this is actually going to be hard-coded to say I don't want any prompting. Gee, this is not quite the, there we go. So the machine that I'm going to connect to in sysalex string here is bobcomp5. That was my machine at home. So this one is actually going to try and connect through SQL OLADB to the SQL server on bobcomp5. It's going to use a connection string called pubs_u, and that's a user that I put in whose default database is pubs. So it's as quick as possible. You realize that if you do use SA and the default database for SA is master, then you always go through master to get through whatever database that you want, and it's actually an extra hit on the database to do that. If you don't realize that, look at Robert Barnes' stuff about transaction server tuning. There's a nice transaction server tuning toolkit, and it'll tell you all about this kind of stuff. But I have a user called pubs_u whose default database is pubs, and that just happens to have a password. It's pubs_u. Now I want to go and turn off the OLADB automatic services. So what I do, I'm right here, is set the fourth initialization property, in fact down here, to enable all but disable resource pooling. And what disable resource pooling is, this string right here, is he says, enable all the services you have, but disable automatic transaction enlistment and connection pooling. Now, if I don't want the object to be a pooled object, I can still use it. I just say enable all. And this overrides the value in the registry. The other way I can do this, if I'm never going to use connection pooling, I can put in the registry, I believe it's all F's, and then the last half word or so is FFFC. But, you can look that up. So now I go and I open my connection, exactly the same way in OLADB. And notice that I keep all these interfaces around. Where am I? Okay, back up here. I keep all these interfaces around as member variables. Right here, the m_ pointer to an IDB initialize interface is kept around as a member variable. And then I'm going to go create a session, and that's kept around as a member variable as well. I have to manage in a pooled component my own state. So I'm keeping all these guys as member variables just the same way that the person who wrote the ODBC component did the same thing. So the only thing to show after this really that's of interest right here is the enlistment. This is what I had up as you came into the room. And the enlistment is done in OLADB through iTransaction join. So I go, and this looks kind of funny because of the interfaces that I'm getting in OLADB. But first I go out and query the iObject context info. That's the place where I get my magic ptran pointer again. I go out and I get the transaction pointer right here, down at the bottom so nobody can see it, Bob. Well, push it up. Okay. Right here, I go out and say, get me the transaction pointer. And now I have an unknown pointer that points to the OLADB the OLA transaction. I use the pointer to the create command pointer because that's actually part of the OLADB session object, which is what I have to enlist in transaction with. I'm enlisting on a session basis. And I use that to get the iTransaction join pointer. And if I have an iTransaction join pointer, then I go and I do the magic call, iTransaction join transaction. Now, here's where the interesting part comes in, and this is why I'm not doing this as a demo today. I know all the people that have your demo scorecards out and say how many demos have failed and how many have succeeded, put them away. I have code. I don't have a demo. Right here, where I do join transaction, the first thing that I have to pass to it is the magic P transaction pointer. The second thing that I have to pass to it is what my isolation level is. Now remember, I'm in a COM+, meaning used to be MTS, environment. And the isolation level, the database isolation level that MTS and COM+ use is serializable. If I set this to 0, which is, by the way, how it looks in your example, so don't forget to write this part down. This is the only writing you get to do. But if I set this to 0, it won't enlist. In the current build right now, it won't enlist. And so don't forget to set this to isolation level serializable, because now your transaction or your connection will enlist in the transaction correctly. Don't forget that's not how it looks in the demo. Here's how it looks in the demo in green. I kept it commented out to remind myself never to do that again. Okay. That's, by the way, how it says to do in the documentation. Don't believe it. Okay. So that's basically all I've done. I've kept my state and member variables. The first time I either get an object being gotten out of the pool or an object being created from the pool, or I actually do something with that object in the OLEDB example, I go out and I set my connection state and I keep my connection state and member variables. Then I decide every time that the object is retrieved from the pool whether or not he's in the same transaction. If he is, I set a flag that, if he is, I just ignore it. If he isn't, I set a flag that says must enlist, and then I go and manually enlist, and that's it. When I'm done with my work, I do, because I was using the old and lousy way, do set complete or set abort, depending on whether my transaction completed or aborted, and I can still do that, by the way, in COM+, and it will still work. At that point, then, I'm done. And what happens is that the pool manager will call deactivate, followed by can be pooled, and actually, this is how it works in the debugger, followed by activate immediately again. So the idea is that at the time that he asks can be pooled, even though I've been configured for pooling, I have the option of either answering yes to can be pooled or no to can be pooled. Okay, so now that you've seen all that code, let's go back and explain it. I told you I was going to do things backwards. Okay, so here's the two pool objects again, specialized using the ODBC API, and the generic OLEDB one. And I actually am going to show you the one for ADO because it's rather interesting. Okay, so for transaction management, I call co-get-object-context. That's the new cool way. Or I can say get-object-context. Then I QI for iObject-context-info, which contains the transaction ID and the transaction object that I want. These over here are the two object-context-info methods that I want to call to get that. And remember that if it's the same transaction ID, don't bother to re-enlist. This is supposed to be as quick as possible. However, this is the transaction ID that I can map to the XID if I'm using XA database. Okay. The other one is the magic P transaction object we need to enlist. Okay. Transaction management here. Here's ODBC. And again, I just copied the SQL connection option out of here and put it in the PowerPoints. Here's OLEDB, which says query interface for iTransaction join. If I get an iTransaction join, join transaction. And don't forget isolation level of serializable. Okay. So that's kind of interesting. What was missing? Well, what was missing is that I don't have to, even though I'm managing my enlistment manually. In fact, I shouldn't, and it'll mess things up if I do. Do not call commit or abort through the OLE transaction pointer that I get back manually, right? OLE transaction pointer, I can do a bunch of things with it. I can enlist it in a transaction. I can manually call commit, and I can manually call abort. Don't do that. The COM+ runtime is going to do that for you. When you get to the root of the transaction, the component that's the root of the transaction, COM+, when that component gets to the end of its method call, COM+ will automatically go out, survey the objects that are out there. It actually does it by means of bit switches, but we can pretend he surveys. Surveys the objects out there, make sure that they all called set complete, and made sure that they're all enable commit, and at that point he will try to commit the transaction. You don't commit the transaction. The other thing is that I enlisted from the transaction. There's also a nice call called unenlist. You don't unenlist from the transaction. If you unenlist from the transaction, what happens is you circumvent the pool manager's managing algorithm that says that I'm going to keep that around just in case you want to use that again. So don't call commit or abort through the OLE transaction pointer, and don't unenlist from the transaction manually. Com+ Services does this for you. You do have to manually enlist. Okay. You also have to disable all the automatic stuff if you want this to work. OADB, or ODBC, for example, will get in the way if you try and use, in some circumstances, the OADB provider for ODBC. ODBC will automatically enlist you in the first transaction he sees. After that, he'll try to automatically enlist you, but you're in a different transaction and that won't work. So the way that you do this is disable connection pooling in ODBC, and you do db propset db init in OADB to disable the automatic transaction enlistment. Again, you can do db prop init OADB services. That was the one we saw in the code. Or you can turn it off for the whole machine in the registry. If you're just using pooled objects and you don't care about transaction enlistment automatically happening, just turn it off in the registry, go to the registry key that has that. You must do this. Okay. Lifetime management. To make this work, you do have to implement iObject control. You probably want to implement iObject control anyway, but it is a requirement because iObject control has the magic method. The magic method, of course, is the method that we used to code all the time before this but never did anything, can be pooled. Can be pooled decides whether or not you can be reused. And I'm going to say this one more time. I'm sorry if you've heard it before and I'm repeating myself, but you can, it is valid to answer yes to can be pooled some of the time and no to can be pooled others of the time. And in fact, it makes for an interesting pooled object. I'm not going to talk about a pooled object like this, but say you wanted an object that would always call no to can be pooled, but you wanted a bunch of them around automatically. Set the minimum number of objects, say, to 100. Set the maximum number of objects to 100. When I get done, call no to can be pooled. If I'm at my minimum, I just drop below my minimum. What will the pooler do for me? Create another one. So now I have like a primed pump to just produce objects at will for me. And I can do this with those three things too. So I don't even need a pooled object to take advantage of object pooling. Okay? The reason in a database scenario why I might want to call no to can be pooled is suppose my database goes away. Now I have a whole bunch of objects that are sitting out there in space that have absolutely valid connections to a database that doesn't exist. Oops. So I have choice of calling no to can be pooled or answering no to can be pooled, or I can try and reconnect again if there's something goes wrong with the database. We'll talk about that a little later on too. So again, you can call can be pooled all you want. If you're not configured as poolable in the Com+ Explorer, it won't have any effect whatsoever. So activate, I can either set or reset to initial state. Remember, activate is going to be called every time it's deactivated, can be pooled, activate again. And I have at that point in activate the object context and the transaction context. So I have both of those things. Deactivate just returns the object to a pool. And what's interesting is that if you have a pooled object that participates in a transaction, it's only going to be returned to the unenlisted pool when the transaction is either committed or aborted, which means that deactivate is only going to be called once. When I get an object and then I enlist it, when I get rid of that object the first time, it's going to be returned, but it's going to be returned to the enlisted pool. Deactivate is not going to be called at that point. Deactivate is only called when the object is returned to the unenlisted pool. And if you want to go home and look at this in the debugger, because I don't have a database to connect to here, so I can't do this for you. Somebody said, well, we should look at it in the debugger. If you want to go home and look at these objects in the debugger, notice how at transaction end, you're going to see a call to deactivate, followed by can be pooled, immediately followed by activate again. It's rather interesting, even before another transaction starts. Follow it. Okay. Construction string is sort of oblique to this discussion, but I'm going to mention it anyway. If construction is checked in the COM+ Explorer, I implement iObjectConstruct. And iObjectConstruct is called for me by the COM+ runtime after the C++ constructor. You use the pointer passed to construct to QI for the iObjectConstruct string, and it allows you to configure things. I mentioned this before already. Remember, though, that you don't have a transaction pointer yet, and you don't have a transaction ID yet, so don't QI and get the transaction ID. It's useless. It's always going to be different, and in fact, it's going to be different than the one that shows up in Activate. Plus, it's going to take up a lot of cycles doing nothing. Okay. Now, I'm going to talk a little bit now about generic data objects, because I want to try and make this generic as possible. If you've seen data objects modeled, the way that data objects are sometimes modeled is one data object per table. I have an object for the customer table, and an object for the password table, and an object for the... And each of those objects composes the database accesses for that table. This is nice, but it's only nice if you have 30 tables or less, because when you get to 150, 200 tables, it's kind of difficult to maintain. You have one object per table, and now you have 200 objects, one for each table. Your COM+ Explorer starts to look like that guys did this morning in the big session, with like millions of objects down the thing. So the other difficulty is, if I have one object per table, where do I put the joins? And I've actually seen some of the things, the original Island Hopper demo does this, that actually does joins in code. Probably not a good thing to do if you bought a database. That's what you bought it for. So the other thing is that business objects, if you have this kind of theory, are tied to one data access per call. And again, you have millions of them. So this is the way this model looks, one data object per table. If I do a use case, I call a business object, which calls 1 to n data objects, and each of the data objects is responsible for one hit against the table. Like I said, not really optimum. So this is data sources as pooled objects. Now, this is not the same as an old ADB data source object down here, but the idea is that the business objects all call into a generic object called the operations object. All the operations object knows is what to do and what component, what object to call to do that I/O. So if I have, for example, SQL Server I/O and Oracle I/O, what I might have down here is one data source for SQL Server and one data source for Oracle. And the operations object knows which specific object to call. What's nice about this is that in this kind of scenario, these bottom level objects here, these ones that say data source, if they're homogeneous pools, I can make each one of them pooled objects. So now I have a homogeneous pool that goes against the pubs database, and I have a homogeneous pool that goes against the orders database, and one that goes against the DB2 database that does something else. So this is where you use these pooled resource objects, and I have an object that uses this kind of method, and I'll show it later on if I have time. But this is the idea of reconstructing database access to go through these data source objects that use homogeneous pools. Again, the automatic pooling mechanisms of OLEDB and ODBC attempt to do this for you as well as they can. The problem is they don't really know what you're going to call with. If you're making these up yourself, if you're writing these data source objects yourself, you have internal knowledge of what specific databases you're going to call against and how many different ones of these you need. Okay. So OLEDB pool generic objects. The bottom tier manages a homogeneous pool of connections. There's one per data source and user ID, because remember, I'm not going to reset the user ID each time. To do that would require closing the connection and reopening the connection. If I change the data, for example, if I change the orders access or I change some access from a SQL Server database to an Oracle database or vice versa, then I just remap them to a different bottom level object through the operations object. And again, the bottom level objects in this scenario are perfect for object pools. Okay, now let's talk a little bit about ADL. I'm using OLEDB and I'm writing my objects in C++, and this is just great and hunky-dory for me. However, there might be a whole bunch of people out there that I have to support that don't want to write all their objects in C++, and they might want to write them in other languages like Visual Basic or Java. And these languages don't support OLEDB intrinsically. So what I might want to do is, thank you, what I might want to do is pass in things that are ADO, do my I/O with OLEDB, and then pass back things that are ADO. I specifically want to pass back things that are ADO when I want to pass back a disconnected record set, because one of the great things that ADO brought to this party is the concept of a disconnected Marshall by value record set that gets marshaled by value across the network. So I might want to return those things. And in this object that I hope I have time to show, that was the 15-minute break. That's who I said OK to. The OLEDB object is called from an ADO environment, or every client in the world has to be OLEDB, which is impossible. Each call in this object passes in a command parameter object, which is actually an ADO disconnected record set just shaped to the right fields. And then there's a generic getObject method, getData method, that goes out to the database and returns an ADO disconnected record set. So I want the best of both. I want OLEDB for access, for speed, and for manual transaction enlistment, and I want ADO for the Marshall by value record set. So how do I do this? Okay, calls must mix ADO and OLEDB. The parameters are going to map to an OLEDB command object, and the return row set is going to be mapped to an ADO record set. Okay. How I do this is it turns out that if you look in the type library and reverse engineer it to IDL with the tool to do that, you'll notice that if you look in the ADO type library, there's these three nice interfaces that you can use. The one that I'm going to use in this object is called iConnection Construction. And iConnection Construction, what this does is it allows you to pass in an OLEDB data source object and an OLEDB session object, which encapsulates the session in OLEDB, and it will return you back an ADO connection object. Cool. This is what I want to do. This is specifically what I want to do because in order to manually enlist in transaction, I had to use those OLEDB objects right now. Okay? There's two other ones that I just mentioned in passing just in case you want to do any of this at home. There's one that maps an OLEDB command object back and forth between an ADO command object, and there's also one that maps a record set to a row set, and vice versa. And again, you can call OLEDB to ADO or ADO to OLEDB. So let's look at the code for that. Code. Okay. Let's look at the code for that. That's probably the biggest interesting thing about this code. This is the SQL. It's called SQL adds because what it manages is a homogeneous pool of connections to a SQL Server database. Here's the construct, and here's the can be pooled. Here's get data. Okay. So again, I'm doing lazy construction. If I haven't constructed it yet, I'm going to construct it the first time. And I'm going to do transaction enlistment if I wanted to enlist in transactions. And I put a little nicer error handling in. I use these macros to throw errors because this is all between a try-catch lock. So I'm actually going to throw errors rather than return an H result. Now, in order to do this, this thing, the wrap DSO in session, requires IUnknown pointers. And so I'm going to QI for IUnknown from the data source object that I have and the session object that I have. This is right here. So now I'm going to get an IUnknown pointer to my OLEDB data source object and my OLEDB session object. At that point, I'm going to create a blank. And notice this is a mixture of the two COM dialects even. I'm going to create a blank connection pointer to an ADO connection. So I go and say pcon.createInstance _ UUID of ADO connection. So now I have a blank connection object. It's not connected to anything. And as you remember from last time, I now have an enlisted on a transaction session object, which ADO can't do. So I call the magic command right here, and it only looks magic if you haven't done it before, which is iConnection construct wrap DSO in session. Now all of a sudden, I've wrapped my OLEDB stuff to ADO. So now I'm free to go back and use the generic ADO stuff to go out and do my command right here, and I'm going to attach the record set pointer and all this good stuff, and use the command pointer because, like I said before, it passes back, it uses parameterized queries always. And I'm actually going to go out and figure out which object I should get or what my SQL command is from another object called the gateway object, which I'm not even going to bring into this discussion. I'm going to take my record set of parameters and make those into a command, parameterized command. Detach my record set of parameters. Make this guy the active connection for that command. Change the cursor location, because now I'm playing straight ADO here. Change the cursor location to ADU's client. So now, not only am I going to be within a transaction, but I'm going to return back a nice Marshall by value record set. Okay? So I have also a flag in here to decide whether he wants to be updatable or not. Then open a record set using a command object, disconnect the record set, and pass it back to me. Basically, that's what I'm doing. If I get any of these errors, I just stream out an error, and I'm going to call my I support error info, which I support. So the idea being that I can certainly mix OLADB and ADO for the things that I need. Okay. A couple of special considerations if I want to do this game. All the COM interfaces that I use in OLADB, notice I stored in member variables, all those specific interfaces have to be thread neutral. Or you know, they have to be able to be accessed by different threads. If they use any kind of things in thread local storage, this will not work. Also, any COM interfaces that I store as data members have to be thread neutral because they're going to be used on different thread probably each time. And so what I should do if I'm trying to do this with OLADB is not trust that, well, everything worked the first time, so it's okay. Make sure that I check with my OLADB provider, check the documentation to make sure that the provider is thread neutral to that extent. It doesn't have to be an OLADB provider. Okay, one more slide about using ADO with COM+. Under MTS, you should never put ADO in a COM+ package, or I'm sorry, in an MTS package. In COM+, I can actually use ADO in a COM+ application. And there's a special checkbox that I check that says, ADO promises not to call, set complete or set abort or enable commit or disable commit. That's just an aside about using ADO with COM+. It's different from using ADO with MTS. Okay, one more slide about error handling in pooled objects. The ODBC and OLADB connection pools handle the idea of errors very nicely. In fact, the ODBC 3.5 even has a configurable retry wait timeout. That's what that retry wait timeout means if you've seen it in the box. What that means is if I somehow lose my connection, don't spin around in a circle trying to get the connection back again because it's probably possible that the database is down right now and you're not going to do anything but waste a whole bunch of cycles. So ODBC has a nice configurable back off timeout. And I'm going to back off for 120 seconds before I try and get that connection again. If you write a pooled object, a pooled data resource object, you have to handle this yourself. So figure out some way to handle it. Either I'm going to return a nice quick, I can't get a connection, I'm sorry, my connection is broken. I can retry the connection, or I can answer no to can be pooled. Okay, so the call to action for this talk is to go out and build some pooled resource objects. You have the SDK, you have the providers, you have everything you need. And also you can use pooled resource objects with compensating resource managers. And if you haven't heard about CRMs yet, shame on you. You should be going to some of the other COM+ talks where they're going to talk about it. Some of the other talks of interest to you might be the Building COM+ app session, although that was yesterday. It's kind of late for it. The COM+ internal section may be where you're all going after lunch. I'll see you there. And there's an OLADB service components section. Don't forget the OLADB docs. And don't forget to read your COM+ preview docs. Don't forget to look in the docs directory when you install that, because there's a whole lot of nice documentation there that might be of interest. So that's all I have. Are there any questions? Thanks. Question?
How would you compare the performance, any ideas on the performance of this kind of transaction versus a classic ODBC load up an object type of stuff?
What I've heard, although the question was, how would I compare the performance of this kind of scheme to a regular ODBC connection pooling where my connections stay in the pool?
Yes.
I haven't done this myself, but what I've heard is that the connection is 300 to 500 times faster. And sample bank component will supposedly run its method 2 to 4 times faster with the pooled objects.
Secondly, generally speaking, the old way of doing this was execute an SQL, load up an object, and use it.
Right.
We're now getting all the benefits of COM+ and Langdon through COM+.
Mm-hmm.
Can you compare the performance, any comments on the performance between the really old way to do it and using MTS?
There's some, the question was, how would I compare the really old way to do it, which was to keep a connection in memory all the time,
sure,
or to keep connected all the time,
sure,
as compared to the connection pooling method as compared to this method. Yeah. Actually, Robert Barnes has a nice comparison in his MTS performance analysis toolkit of the first two. And actually, it turns out that although, remember, connection pooling, the reason why I use connection pooling isn't always for speed. It's because you might have a web application where you might get 1 million connections 1 minute and no connections the next minute. But really, the idea that you hold on to a connection the old-fashioned way is actually a little faster.
Yeah.
Yeah, read his.
A little faster being the key comment.
Yeah, a little faster. Read his documentation. It's a little faster. Also, I have to go talk to him about this. His comparison of database access methods compares ODBC to OLADB, and ODBC comes out to be a little bit faster. But he also says that file DSNs are really cumbersome to use because you have to read the file each time. Yet in the OLADB example, he uses a UDL file. So that doesn't quite jive to me. I have to ask him why he just doesn't use a hard-coded connection rather than UDL. But yeah, he actually showed what people didn't want to see, which was that it is a little slower to do this. But you do get the benefits, other benefits besides speed.
There's only about a 10% delta.
Right, 10% delta. Thanks.
What about the sample code for your OLADB to ADO?
That's actually on the sample codes of the OLADB to ADO may be coming out with beta 3. It's not. The second call of that gateway object, which was a Visual Basic object, is not quite always as nice as I'd like it to be. So supposedly that may be coming out with beta 3. That's what I've heard. It'll be part of a demo that comes out with beta 3. And if you want, I can, I give you my card and I can show you what I have now. The OLADB one, the second one that I showed, is included on the CD. But don't forget to replace that thing with a serializable transaction isolation level, or you'll be wondering about it in the middle of the night like I did. Any other questions? Yes, sir.
What was your comment about ADO having problems with current MPS objects? I didn't understand that. It's on your last slide.
Oh, the second to last slide about how you shouldn't put ADO in an MTS package. Yeah, you shouldn't put ADO itself in an MTS package for performance reasons. ADO is much more performant if you let it execute in the MTS address space, but not within an MTS package, because it's actually going to do, try and do transaction enlistment, automatic transaction enlistment, and things like that. So the way to configure ADO right now with MTS is you just leave it alone. And what happens is the first time you call from any component within an MTS package to an ADO call, ADO will do what it always did. It'll load into your address space, which just happens to be the MTS address space, and you can call it. And that's the way you should do it now. However, in COM Plus for maximum performance, because COM Plus is a nice superset of MTS, you are able to put ADO in a COM Plus application, and you should for performance. And in fact, one of the reasons why that component promises not to call set complete or set abort thing is there is specifically so you can use things like ADO. So yeah, you never put ADO in a package. It ties things down. It ties like connections down to specific threads and things like that right now. Any other questions on anything? Yes, sir.
You can build a component in C++ using OLADB
Mm-hmm.
and use it in MTS,
Mm-hmm.
the current version of MTS.
Mm-hmm.
Are my connections pooled if I use OLADB connections?
Oh, the question was, if I build a component with OLADB native providers and use them right now in MTS in version 2, are the connections pooled automatically? And the answer is yes. If you have OLADB version 2 installed on your system, and you have the provider set up correctly, then there's automatic pooling and there's automatic transaction enlistment, just like they'll be in COM Plus, and it works great.
Okay, so my question was, the documentation says that there's an ODBC manager, the ODBC provider for ODBC manager,
Mm-hmm.
resource dispenser.
Right.
But they didn't say that the native OLADB providers are also resource dispensers.
No, the question was, are the native OLADB providers resource dispensers? Are the individual providers themselves? And they don't specifically have to be. The OLADB service components aggregated on top will actually be what does the resource dispensing. So it's not the providers themselves. You do have to do weird things, though, if you write a provider that talks to XIDs. You have to talk to the MSDA Aura folks at Microsoft that wrote that one.
Thank you.
Yes, sir.
Did I understand you correctly that if you have to support some DB applications that were using disconnected ADO record sets, and you want to take advantage of this pooling
Mm-hmm.
feature, that you'd have to build a component using the OLADB, and it would have to have a neutral threading model?
Well, there's three choices. The question was, if I build one of these components, does it have to have a threading model of neutral? This is a new threading model that comes with NT5, a neutral threaded apartment. And there actually are three choices. I can have it run in the neutral threaded apartment. I can have it run in the MTA, the multi-threaded apartment, if it's only going to be called by MTA components. Or I can have it as threading model of both. And the pooler will actually make sure that you're in the right context when you need to be.
Right, but if I'm calling this from VB,
Mm-hmm.
then would it have to be neutral?
If I'm calling this from VB, it would have to be neutral or both. Right, can't be MTA, because VB things aren't going to be in the MTA. But I made these ones as both, and they work fine. Any other questions? Oh, how many minutes do I have? Time's up. All right. Well, if you have any other questions, I'll be up here for a while, and because it's lunchtime. Thanks for staying through lunch, everybody. I appreciate it.